All right, so an important thing to remember in this question is that when something is colliding, it means that they're equal. So the point of collision is when this one is equal to that one, this one is equal to that one, and this one is equal to that one. So we're going to set our equations up like that first to make it a little clearer. So cos AT is equal to BT over 2. 2 sine AT is equal to root 3 BT. And negative root 3 cos AT is equal to root 3 on 2. Okay, so I've got my I components, I've got my Y components, I've got my I, J, and K components all lined up. Now it's going to be a matter of just rearranging things. So I'm going to first take this 2 across to that side. 2 cos AT is equal to BT. And then this side, I'm going to take this negative of the root 3 across. So that's going to become 2 sine AT divided by root 3 is equal to BT. Now I've got these two equal to the same thing, which means that I can, make them equal below. So we're going to solve them simultaneously. Solve for BT simultaneously. Oh, sorry, AT, because we're going to get rid of the B in this. So 2 cos AT is equal to 2 sine AT all over root 3. Okay, so now that we've got that sorted out, we're going to do some rearranging. So first thing I'm going to do is I'm going to take this 2 over to this side here because they'll cancel out. Now I'm just going to scroll down so we can see things a little bit clearer. That's going to leave me with cos AT is equal to sine AT all over root 3. Now, if you did a lot of stuff on trigonometry, you'll remember that if we've got sine and cos, sometimes we can turn them into tan. So if I take this root 3 up over here, and it switches places with that cos, so it comes up, root 3 is equal to sine AT divided by cos AT. That's the same as saying root 3 is equal to tan AT. Now, I can separate the tan away from the AT by taking the inverse of it. So the inverse tan root 3 is equal to AT. Now, that's like saying what angle will give me root 3 for tan. So if we think back to our unit circle, here it is. The ones that will project to give tan positive values are in these two quadrants here. If you look at the initial question, it's posed to us that the domain for this is between minus pi all the way up to 0. Now, let's just double check that because these can be a little finicky. Okay, it's A, and we're looking at including those things. A, including. So that means that we're not going to be looking at this one. We're going to be looking at traveling in this direction because we only want from 0 to minus pi. So either you can use your hand trick or see what you can remember, but you should have got that is going to be 60 degrees will give you root 3. So tan of 60 degrees is equal to root 3, which means that if I'm looking for the one down here, I want to be working in radians, so pi on 3, and I also want to do the minus pi plus that to see how far I travel going in that direction. So it's going to be minus pi plus pi on 3, which will give me minus 2 pi on 3. So AT is going to be equal to minus 2 pi on 3. Now, I'm pretty confident I'm only going to need one solution for this one. Okay, so now I've got the AT. Let's see where we can start looking at substituting this back into. I've used this. We haven't used that one. Looks like this one's going to give me something pretty easy to work out. So let's give that a red hot go. Now, I did forget initially to put the T on the end of this one. but there is a t there. So we're going to substitute this into the k coordinates. Okay, so we're going to let at equal minus 2 pi on 3. So minus root 3 cos minus 2 pi on 3 is equal to root 3 on 2 t. Now this allows us to solve for t. So all I have to do is work out what cos of 2 pi on 3 is. Now if you look over here, you can see that it's going to be a negative value. So it's going to be like negative root 3 times negative. Now cos of 60 degrees, if I think back to my hand trick, is going to be a half, is equal to root 3 on 2 t. So these two here will become root 3 on 2 is equal to root 3 on 2 t. If I take this up, it's going to cancel out that 2. If I take this one down, it's going to cancel out that. I'm going to be left with t is equal to 1. So I've now found that the time of the collision is going to be at 1 second. The next part of this is to find out where they collide. So if I want to find the position of their collision, all I have to do is substitute them all back in. But I don't have enough information yet. Now I've got AT here and I've got T. So if I find B, I've got all the information I could possibly need. So now we're going to solve for B. Now I'm going to do that by just substituting it back into this one here. So you could have picked any of them though. Cos of minus 2 pi on 3 is equal to B times 1 on 2. We've already determined that that is going to be equal to negative a half, and B is over 2, so therefore B is equal to negative 1. Okay, so next thing we want to do, that's it for, oh, no, we didn't find where they collide. So, position of collision. Now we're going to substitute this back into the first one. I wish that we could get this onto one screen. I'm just going to take a little snippy snip. All right, and then we're just going to post that in. Okay, I don't know what's happening. Okay, so there we go. So now I can substitute into this to find the position. So RA, when time is equal to 1, is going to be cos of minus 2 pi on 3 I plus 2 sine minus 2 pi on 3 j minus root 3 cos minus 2 pi on 3k. All right, now all I have to do to work that out is throw in what I know. So I know this part turns into minus a half I plus this here. Let's just quickly do my little diagram again. We know it's going to be 60 degrees. So sine of 60 is going to be, it's going to be negative root 3 on 2 times the 2 that's still in front, minus root 3 times negative a half I. So in total, this works out to be minus a half I minus root 3j plus root 3 on 2k. All right, perfect. Next part of this question is to justify the reasonableness. So in order to do that, we want to prove that this will turn out to be the same as the other. So again, I'm just going to steal a little snippy snip, just so I don't have to write it all out again. Now, you could have put the exact values into your calculator, but I don't think it's any faster. Okay, so Now we're going to substitute into RB and prove that they're the same thing when time is equal to 1. So B was equal to -1 and T was equal to 1. I plus root 3, B was equal to -1, T was equal to 1. J plus root 3 of 1 on 2K. All right, so that's going to give me -1 on 2I plus minus root 3J plus root 3 on 2K. All right, so now we just finish it off with a little statement. Therefore, RA is equal to RB when time is at 1 second. All right, and that should be enough of a validation.